Hello everyone, and welcome back to AMOS, our project on agile methods and open source. We are in the middle of the practices of agile software development that are carried out by a software developer in an agile methods project like a Scrum project. We looked at the overall organizational issues and also the detailed practices, and now we will look at one particular aspect of agile methods that was brought in mostly through extreme programming but clearly can be viewed as independent of it, which is test-driven development. When we talk about test-driven development, we are automatically talking about testing your software. But I will not go into a lecture on testing itself, but rather on test-driven development, a small or minimal method, if you will, maybe the smallest possible agile software development method there is, which is typically part of most agile software development projects these days. This slide deck actually is very close to another one from our course Advanced Design and Programming, which is a bachelor course. There you should have learned all you need to know about the basics of testing, test-first programming, and test-driven development. Here I will repeat some of the core lessons to make sure this is viewed properly in the context of agile software development. So we will look at these three topics: tests and testing, only very quickly, shortly, then test first as a historical development, and finally what we have today, test-driven development. When we talk about tests and testing, we need to recognize that testing is a process with the goal of aiding quality assurance of the delivered software artifacts, results typically. And that as part of this process, we have something of concern or some object with respect to its correct or expected correct operation. Ideally, there's a specification for that operation, and the test is supposed to verify that the object behaves according to that specification. When you start out programming, you probably test manually most of the time. Ideally, testing is automated, and of course, that's what we will be looking at later or in a few slides. Tests can never show that your system is correct. It can only detect bugs, so it will be helpful, but not or never a guarantee of correctness. Basically, from a pragmatic perspective, if you have lots of tests, if they are well done, if you get good test coverage, all of that, you increase your confidence of delivering good software, but you can never be sure. We talk about component tests, acceptance tests, and integration tests as a very rough categorization. This is certainly a simplification. Courses on testing will provide you, quality assurance and testing will provide you with a much more detailed distinction here. Component tests are simply tests focused on a single component. So you have to cordon off that component for testing purposes. Acceptance tests are tests that test not the individual behavior of components, but rather some function or functionality that typically crosses by way of its control flow multiple components. So you're literally testing a slice, if you will, of the system. And integration tests are system tests, basically try to ensure or test that the whole made up all of its various pieces fits together well, so that the integration of various components, possibly independently developed components, that's where it's coming from, actually works and does what it's supposed to. In industry, you sometimes hear people talk about end-to-end tests, and they usually mean both acceptance and integration tests with that. Not a very clear use of terminology, so we avoid it here. These are the basic terms from testing. You have a simple test case which tests one particular function or functionality. A test suite is an aggregation of multiple tests. Test setup is how you prepare the system for testing, so how you initialize it, set it up for proper testing. Test results is what you get as a result of running one test, or test suites, meaning test failures where the system did not behave as expected, and test errors where somehow executing the tests themselves failed. And to do all of that, you typically need a test harness, something like JUnit, or some framework that lets you easily implement and execute such tests. On then to test-first programming. After clarifying the basics, we now need to recognize historically that while tests and testing has always been around, there was an important shift in thinking in the late 90s, early 2000s, where we recognized that testing may not just be an activity of quality assurance, classically a department separate from software development, but it may be a job for regular software developers performed as part of their regular development duties. And that's how Agile methods view it. Testing is an important part of software developers do to confirm not only their belief in the correct functioning of the system, but once more as a feedback loop they want to engage and have in software development, for example, to maintain a predictable software development speed or velocity, as discussed in product management and product ownership and planning Agile software and tracking Agile software projects. So test first, I think coined by Beck, published, the book was 2002, is a practice in which developers actually write the test before they implement the associated functionality. So you write a test and it may not even compile in the very first step because there is no function to test against. So it's a declaration of intent, and you engage in a loop of back and forth where you first think about tests, then you write those tests, then you don't even compile, then you fix that by implementing an empty test, then that test case for the empty functionality, the test case for the empty functionality will fail, then you provide the simplest possible implementation of that test, and then you start extending your test suite to cover more complex cases. So there's an iteration loop here on the level of create a test, implement the functionality, add new tests, extend the functionality, and in ADAPT we explain this in more detail. So interestingly then, the main functionality that a software system is supposed to provide develops or follows as a function of you writing tests to make sure that the desired behavior is there. And this has some benefits. As you, in classical programming, you get a specification or get some idea of what you're supposed to do, and then you implement it. So you have the perspective of the user, even the technical user or programmer within the system, and that's exactly one perspective. Test-first programming gives you that second perspective, that of a test programmer. So now you have two perspectives on your codes, one from a testing perspective and one from how is the user, technical user, programmer using that function. And just this very basic fact that you have two perspectives will make your code much cleaner, because two perspectives are better than one. You straighten out the code much faster, much quicker, you gain a broader understanding, and hence you have cleaner, clearer code. In addition, as you build your tests, you're building up large test suites, which in the context of Agile software development, again, will help you gain more confidence and help you maintain development speed, as you are unlikely to suddenly hit a snake pit of bugs that were somewhere lurking in the system. At least you won't typically if you have good, sufficiently large number of tests with appropriate test coverage of the system. So here's the basic rule of test-first programming. You should only be writing new code, new functionality when a test fails. And so you first have to write a test that then fails, and only then are you allowed to write new functionality. Once you've done that, once you wrote a test which failed, and then you wrote the code that fixed up that test, you switch to the third step, which is clean up your code, eliminate waste, remove redundancy, refactor appropriately so that you maintain high code quality, clean, predictable code. In testing with JUnit specifically, but in general also, this has been codified as this 3-step of red, green, refactor. A nice shorthand. Red means the test is red, the test fails, then you make the test work, so the test or JUnit becomes green, and then you refactor in order to keep your code base clean, after which you start over with red and then green and then refactor and on again. Finally, after test-first programming was formulated, it evolved into a test-driven development, which is now considered, or at least considered, a minimal software development process derived from test-first programming, which turns features from a product backlog or any sort of specification, as basic as a to-do list, if you will, turns those features into reality, into implementations. Now, the purpose of test-driven development is similar to test-first programming: grow the product incrementally and steadily while maintaining a consistent code quality so that you can maintain a consistent development speed. And once you have that, not only can you more easily predict how much you'll be able to deliver by some point of time in the future, you also always feel confident to release pretty much at any time. So that's very helpful if we have very short iteration cycles like 1-week sprints. And it certainly is a requirement if we have something that we will look at a bit later, which is continuous deployment, where literally every single commit that a developer makes is turned into a new deployed version of the software to make software development as fast as possible while still being responsible towards your users. Here is the summary of test-driven development as a minimal software development process. At its core, it is about turning a feature request, a functionality, into reality. So you start out with step 1. You read up on a feature like a sprint backlog entry, and you start developing a test for it. A first test, certainly not testing all of the feature, but one most basic aspect perhaps, which then fails. The test fails. There is no function. It doesn't even compile perhaps because there is no implementing code. So you move on from writing a test to implementing the feature in order to make the test green so it doesn't fail. Once you've done that and the tests run through, you still know that you probably didn't fully implement the feature, so you go back to the test suite and implement more tests. You iterate over from tests to implementation, back to tests to implementation. At any given point in time, you may have to refactor both your test suite to make it simpler and your implementation to make it simpler and easier and more maintainable. And so you iterate over these 3 loops from test to implementation and from test to test, or implementation to implementation for cleaning up code. And once you believe you cover the whole feature, then you can leave this small loop and move on to the next feature, which is illustrated here. The easiest way of looking at requirements is as an incoming stream of prioritized feature requests, requirements, which get picked from the stack. So the most important one will be picked up by the next developer becoming available for work, who then works on it, and so forth. So you can see how one feature after another is being pulled off the stack, being implemented, and put into an archive. After the top most highly prioritized feature has been removed from the stack, the next feature becomes available for the next developer to pick it up. And so you go through this basic loop of picking off a stream of features, the functionality you want to implement, and you're making steady progress on the overall product being developed. That is the essence of test-driven development. The core process we saw a slide ago, and then the stack of incoming features that you work off incrementally and steadily using a test-first or test-driven development approach. Well, that's it. Again, much more can be learned in our course on advanced design and programming, now also on YouTube. And today we learned, or in this segment, we learned about the basics of tests very, very quickly, and certainly to be done much more nicely in a proper lecture on testing and quality assurance. We understood or learned about the historical position of test-first programming as the precursor to test-driven development, and then reviewed test-driven development as a minimal software development process, even smaller than Scrum, and still viable. That's it for now. Thank you very much, and we will continue with our next slide decks later.